On number 20 it says, if an archer shoots an arrow straight upward with an initial velocity of 128 feet per second from a height of 6 feet, then its height above the ground in feet at time t in seconds is given by the function h of t equals negative 16t squared plus 128t plus 6. So the most important thing starting here is making sure that you know what your variables represent. So notice first of all that t is time and h of t is going to represent the height. So let's go ahead and look at A here. It says, after how many seconds does the arrow reach its maximum height? Well, this is a max-min problem. And we know, first of all, if you look at this function, its graph is a parabola. Whoops, let me move that back. That opens down. And so we would expect to have a maximum at the top there. And we know we find the maximum or minimum at the vertex. So let's go ahead and write the formula, x equals negative b over 2a. Now notice here that really t is acting like x because that's our input value, which represents time. So really it's t equals negative b over 2a. Notice a is negative 16, b is 128, and c is 6. So I've plugged in negative b. 2 times a, that'd be 2 times negative 16. So this will be negative 128 over negative 32, which is 4. Now remember, t stands for time, so we actually have answered the question here. It says after how many seconds does it take to reach its maximum height? That would be 4 seconds. Now in part B it says, what is the maximum height of the arrow? Well, one thing we learned is that a maximum or minimum is the y value of the vertex. So all we need to do here is plug in 4 into the function to get our output or y value. So h of 4, let's plug that into the function. Now you can put this into your calculator and what you should get is 262. Now this is a height. Notice we're dealing with feet here. So this represents 262 feet. So after 4 seconds, we reach the maximum height of 262 feet. Let's move on to number 21. So it says use the rational zeros theorem to list the possible rational zeros of each function. Now this is the problems where we use the p's and the q's. And we know that any rational zero, that's any number that can be written as a fraction, would have this form p over q, where p are the factors of the constant 5 and q are factors of the constant 2. So let's go ahead and write in our factors of 5. Don't forget to do the plus or minus thing. So that would be plus or minus 1 or plus or minus 5. And then we're going to put that over the factors of 2, which would be 1 and 2. So the way I always think of it is I take the 1 and 5 and first put them over the 1. And so we're going to get 1 and 5. Notice I'm putting the plus or minus out front. And then the numbers will go inside braces. And then I'm going to put 1 and 5 over my other denominator, which is 2. So 1 over 2 is a half. And 5 over 2, that would give me my other 0. So there's 4 zeros, actually 8 here if you think of the positives and the negatives. So let's move on to B. So our P and Q, P is 15 and Q is 3. So let's write down the factors of P are 15. And then the factors of 3, that would be 1 and 3. And so we're going to take all these numerator factors, 1, 3, 5, and 15, and put those over 1. That's just going to give us each of those, 1, 3, 5, and 15. And then we'll put each of those over 3. Now when we do 1 over 3, that's going to be 1/3. 3 over 3 just gives us 1, which we already have. Then 5 over 3 will give us 5/3. And 15 over 3 is 5, which we already have. And so that's going to be it. Let's move on to 22. So here it says we have a function. We need to find the possible zeros. That's what we were just doing. So identify P and Q. Let's write our factors of 9. That would be 1, 3, and 9. And then our factors of 2, that would be 1 and 2. So we're going to put all of those over 1. That gives us 1, 3, and 9. And then we'll put all of those over 2. And so those are going to be our possible zeros. Now notice in part B it says you may use a calculator to find your first zero. It should be one of these numbers that we just found as possible zeros. So if you look on the calculator, you should find that 3 is a 0. I should have said 0 there. Let's go ahead and do synthetic division now with -3. So remember we dropped the 2, and then we're going to multiply, and then add, multiply, add, and multiply, and of course we expect to get 0. So now we can actually factor this function down. We can write f of x as, let's see, if x equals -3 is a 0, then we know x plus 3 is a factor. And our other factor is going to come from our answer here. So let's put that in. And now this part here, we ought to be able to factor. We can use the AC method, and if not, we'd have to use quadratic formula. But this one actually factors. So let's do a chart. 2 times 6, or 3 is 6, and that's our AC. B is -7. And it looks like it's going to be 1 and 6, and they should both be negative. -1 times -6 is 6, and -1 plus -6 is -7. So let's go ahead and split our B term. We can't take the shortcut on this problem, because notice our A here is not 1. So let's go ahead and split our B term, and factor by grouping. We can factor out an x. So we expect a 2x minus 1 in the other, and we're going to need to multiply that by -3. And so we're going to get 2x minus 1 times x minus 3. So now we can rewrite the function in factored form. And now by setting each of those equal to 0, you get your zeros. Now for x plus 3, we know -3 is our first 0. We know 3... Let's see, 2x minus 1, let's go ahead and set that equal to 0. And when you solve that, you do get a half. So that's our second 0, and then don't forget the 3. Let's go ahead and look at number 23. So our zeros are going to be 5, -4. Let's see, I'm going to set 3x minus 2 equal to 0. And add 2 to both sides and divide by 3. We're going to get 2/3. And now we're supposed to give the multiplicity of each. Now remember, the multiplicity is determined by how many factors we have that correspond to each of these zeros. So x minus 5 is to the 4th power. So our multiplicity there is going to be 4. And for -4 it'll be 3. 3x minus 2, that's to the 1st power, so our multiplicity there is 1. Alright, let's move on to the next page. Now I messed up when I was getting this ready, so we'll actually do 24 at the end here. Let's go ahead and look at 25. So first of all, if you look at a rational function, the first thing you got to think about is, what can x not be? Do I have any restricted values? We know that a fraction cannot have a denominator of 0. So in this case, if x were -2, we would be undefined, because -2 plus 2 is 0. Our denominator 0 were undefined. So our domain will include everything else. Now, we don't even care about the numerator. If the numerator is 0, then the whole fraction equals 0, and that's fine. So it's just the denominator that we got to look at. So our domain is everything except -2, and that's how we write that. Now, wherever our restricted value is, that's where we're going to have a vertical asymptote. So we already did the work for that. Now, for horizontal asymptote, we want to look at the degree of the numerator and denominator of the fraction. So in this case, they're both 1. And so in that case, we take the coefficients of the leading terms, that would be the 3x and the 1x, so 3 over 1, and that's going to simplify to 3, so it's going to be y equals 3. So you may want to go back to, I think it was exam 5, and look at where we had those 3 rules if you don't remember what they were. So when our degree is the same, we're just going to use the coefficients of the leading terms to find our horizontal asymptote. On part B here, let's go ahead and set x squared minus 4 equal to 0. I want to know when my denominator is 0. Now this is a difference of squares, so let's go ahead and factor this. And so we're going to get 2 and -2. So our domain, basically that's what x can't be, because that causes my denominator to be 0. I'd be undefined. So x can be anything else. We'll go from -infinity to -2, and then we're going to have to go from -2 to 2, and then we're going to go from 2 to infinity. Notice it's important that you use parentheses here because we're not including -2 or 2 in our domain. Those are our restricted values, so that's where we'll have our vertical asymptotes. Notice you should write each of these as a separate equation. Now if you look at the degree of the numerator and denominator, it's 1 over 2, so this is what we were saying was bottom heavy, and in this case it was y equals 0, or I should say our horizontal asymptote was y equals 0. So anytime the degree in the numerator is smaller, y equals 0 is going to be your horizontal asymptote. Let's move on to 26. So first of all, we need to identify the 3 parts. The base is 64, the exponent is 1/3, and the 4 is what we've been calling the answer. And so we should be able to change to logarithmic form and write the same 3 parts in the right places. Remember, we got to know this, got to know where our parts. So we write log, our base is 64, the answer goes next, and the exponent, remember the exponent goes all by itself when you're in log form. And so that's going to be our answer there. Notice base, exponent, answer. So let's do the same thing with the other one, or there are 2. In part B, so go ahead and write log. Our base is 5. The answer goes next. And again, the exponent goes on the other side. So you can always go backwards. Notice if you take the base, 5, to the -2 power, that is going to equal 1 over 25. So we can check it by doing that, by going in reverse. On this last one, it might be helpful to go ahead and write this as log base e, since it's a base e log, even though we know this is going to be an ln, or natural log. And then the 5 goes next, that's my answer. And then the exponent goes all by itself. So let's change that to the natural log form. That's what ln means, log base e. So the natural log of 5 is equal to 0.12x. Alright, I'm going to go ahead and stop this video, and I'll create a new video for the next set of problems.